All right, what's up? VL AP Statistics students, Mr. Bachman here. This is your week 5, day 2 lesson, unit 7. We're going to be doing paired T procedures. Here's the agenda. I'll run through a little bit of information about the AP exam and upcoming schedule as I did the day 1 lesson. We're going to fill out another couple rows of the inferences for means review grid. Question of the day, we're going to do a lesson on paired T procedures, and that'll about do it. All right, so remember there were 2 options for the AP exam, so you should know if you are in person or digital. And then I have the schedule laid out for the next couple of weeks. I explained that in the last video. All right, next thing I'd like you to take out or pull up your inferences for means review grid. I have the next 2 rows of the grid. So I have the 2 sample T interval for mu1 minus mu2, and I have the 2 sample T test for mu1 minus mu2. So if you want to take a minute to add those into your review grid, I'll just highlight a couple things. Remember, when you are using an interval, you're estimating something. In this case, the difference between 2 population means. And then for a test, a significance test, you're testing a hypothesized something that's hypothesized, in this case, again, a difference between 2 population means. Conditions are the same for both. Your critical value is T. Your test statistic is also T. Here's the interval formula. P-value, remember you do TCDF. Remember that for both of these, there is a complicated degrees of freedom formula. So remember, what we're going to do in both cases is really just rely on this calculator function, 2samp T int and 2samp T test. So I'll show you that a little bit in today's lesson. Okay, so if you need to, pause the video, copy those down, and we'll come back in a sec. All right, so let's move on to the question of the day. Remember, this will be something that you submit to Schoology. I'm going to read it out loud, and then you can pause the video, do the 4-step process, and then come on back for the answer. So a manufacturer claims that its brand A battery lasts longer than its competitor's brand B battery. 9 random batteries of each brand are tested independently, and the hours of battery life are shown in the table below. Okay, so we have 9 data values for both brand A and brand B. So the first battery that was tested from brand A lasted 88 hours. Second one lasted 85 hours, right? And you can see that, see all 9 batteries there. Brand B, first battery lasted 80 hours. Second battery lasted 79 hours, and so forth. So using 90% confidence, estimate the difference in true mean battery life between brands A and B. All right, so we want to use the 4-step process for this. Again, we're doing a 90% confidence interval here. So why don't you pause the video, work through your 4-step process, and then come on back for the answer. Okay, all right, welcome back. So what you should have done first is typed your brand A values into L1 and your brand B values into L2. And you should have done 1-var stats on each list, and these were the numbers that you should have come up with. So I'm using subscripts of A and B. So X bar A was about 83 hours with a standard deviation of about 5.2 hours. For brand B, that difference was, the mean was 78 hours with a standard deviation of about 2.87 hours. Okay, so what we're going to do is try to estimate the difference between the true values. So we can see that for the sample values, our difference, so this would be X bar A minus X bar B. If we subtract those 2 values, we end up with about 5.33 hours. So that would be the difference between the 2 sample means. And what we want to do is use that difference to estimate the difference between the population means. All right, so we're going to run through the 4-step process. So step 1, I will conduct a 2-sample T interval for mu sub A minus mu sub B. So I named my procedure. Again, it was the 2-sample T interval for mu sub A minus mu sub B, where mu sub A is the true mean battery life of brand A, and mu sub B is the true mean battery life of brand B. All right, and that's all I have to do for step one. I'm doing an interval, so no need for hypotheses here. I do need to check my conditions. I have 2 random samples. That was stated in the problem, the prompt. Both samples are less than 10% of their populations, right? We're taking samples of size 9, so definitely less than 10% of all of the batteries. And then because my samples were pretty small, I did need to make box plots for each of these. So this is, the top one is the brand A box plot. The bottom one is the brand B box plot. I just made those on my calculator and then transferred them to my paper. So the brand A's box plot does have a slight skew. You can see by this lower tail here. Probably not a heavy enough skew though to for this condition not to be met. So I said both sample box plots show no heavy skew and no outliers, right? So those 3 conditions are met, so we can proceed with the interval. So this is now going to be step 3. So what I used is the 2SAMP T interval function. So I'm going to show you that now, and I'm going to put this back up because we're going to need to type those data values into our calculator here. So I'm going to use my, so I'm going to hit stat. I'm going to go over to tests. I'm going to go down to 2SAMP T int. So go ahead and find that on your calculator as well. Sorry, let me move this around a little bit. My apologies. There we go. All right, so, sorry, stat, tests, and again, 2SAMP T int, this one right here. And you have your data in your lists, so you can just leave it like this. You can just put in data, list 1, list 2, and then just go down and change this to 0.9. Keep pooled as no, and then you can just go to calculate. I'm going to have to type in my statistics here. So sometimes you'll have to do this as well. So 83.333, standard deviation 5.244, 9, X bar 2 is 78, and standard deviation 9. Again, I'm doing a 90% confidence level. Again, pooled is always no. Hit calculate, and that will be your interval, and that's the same as what I have here, 1.791 to 8.876. You'll notice that I also wrote down my critical t-value. Now, unfortunately, this calculator screen doesn't give you that critical t-value, but it does give you the degrees of freedom. And remember, the degrees of freedom formula is complicated, but it does tell us here that we have 12.4 degrees of freedom. So what I can do then to get that critical t-value, that's something you want to report, is you're going to go to second vars and inverse t. And my area, so I'm doing a 90% confidence interval. So my area to the left of that, or the area of the tails, the tail probability of 90% is 0.05. And then degrees of freedom, I'm just going to type in that number that I got from 2SAMP T int and hit enter. And that gives me that t-value of 1.777. I write it down as negative since it's plus or minus in the confidence interval formula. Okay, so that is how to use 2SAMP T int, and then as well as getting that critical t value using inverse t. All right, so that's step 3. And we can see that 0 is not included in the interval, so we do kind of have some evidence here, some convincing evidence that brand A does last longer. And then for step 4, we'll do our interpretation. I'm 90% confident the difference between the mean battery life of brand A and the mean battery life of brand B is captured by the interval 1.791 to 8.876. And that is in hours. Okay, so that's your 4-step process for the T interval, 2-sample T interval for mu1 minus mu2. Make sure that gets into Schoology. And let's move on to our next set of procedures. So these are called paired T procedures. So we're going to do a paired T interval and a paired T test. I'm going to run through the 4 steps for each, and then we'll do an example. We're going to start off with this context. Imagine the sensation of swimming through maple syrup. So just kind of envision that. What would it be like? Would you move faster or more slowly than you would through ordinary water? All right, so take a second to think about that. So this problem was actually a problem in one of my old statistics books, and I did it every year. I always thought it was kind of an interesting problem. But I also had this memory. When I was in college, I used to work at the University of Minnesota, the natatorium, the aquatic center, so the big pool. And I worked there until about 2003. And right as I was ending, I kind of heard some rumors that they were going to fill up one of the pools at the U of M with syrup. And I never really heard the end of the story, but that I always had that vague memory when I did this problem with my students. And I did a little bit of digging, and actually I found an article, and this article is linked in the slides. It's also in Schoology. You can take a look at it. It's not the actual academic paper, but it's a little bit of background. But they actually did this experiment at the U of M, and they had 20 swimmers. They had them swim through regular water. They measured their swimming velocity, and then they had them swim through this syrup. So they filled the pool up with this additive. They put it in the water, and it made the water syrupy. It was called guar syrup. And I think what they did is they randomized so each swimmer swam in both, but they did a randomization procedure where they randomly selected what you would swim in first, either the regular water or the syrup. So you can look at that article. It's kind of cool. So here is the data. So and I'll read the rest of it here. So 20 swimmers each swam a specified distance in a water-filled pool, and a pool where the water was thickened with a food-grade guar gum to create a syrup-like consistency. Velocity in meters per second was recorded. So see the data at right. So you can see that each swimmer has a data value for both water and guar syrup. I think most of these swimmers are actually varsity athletes, varsity swimmers at the U of M. So the authors of the paper concluded that swimming in guar syrup does not change swimming speed. That's kind of interesting. And if you look through the data, the numbers are pretty close. Sometimes the guar syrup was a little bit faster. Sometimes the water was a little bit faster. It says, are the given data consistent with this conclusion? So we may think to conduct a 2-sample t-test. That's what we've been doing. But actually, it actually can be a little bit easier because the data is paired. So we're going to learn about this paired t-interval and t-test, and then we'll return back to this problem and actually check it out. Okay, so paired data involves measuring a quantitative variable twice for the same individual or for 2 individuals who are much alike. So in this case, each swimmer has 2 data values. We were measuring 2 different things for the same swimmer. So again, this is paired data. This other piece, 2 individuals who are much alike, you may have heard of a twin study before. So if you have 2 siblings that are twins, a lot of times they're used in like medical experiments where one twin will receive like a placebo, second twin will receive the experimental drug or treatment. And because their biology is so similar, because they're twins and their genetics are so similar, it makes for a good way of comparing. So twins are often used in these paired procedures. So to analyze paired data, we start by computing the difference for each pair. We'll then compute the mean and standard deviation of the difference list. These values will be noted as x bar sub d and s sub d. I'm going to show you how to calculate those really quick. So what I'm going to need you to do is pause the video. I'd like you to type the water values into L1 and the syrup values into L2. So again, pause the video and then come on back when they are typed in. All right. So hopefully you have that data in your lists. I have them in here as well. So what we're going to do is just to kind of see kind of what this is going to look like, what I'd like you to do is in your data, so again, you hit Stat, enter on Edit, you're going to go up to L3. And what we're going to do is we're going to do the difference list. So we're just going to subtract the two lists. And what I've decided is what we're going to do is we're going to take the guar syrup list, so L2, and subtract L1. So let me show you how I did that. Make sure that you go up to L3 so that L3 is highlighted. And then, I'll just clear it so you can see it again. So hit enter on L3. Again, it needs to be up in this, the little cursor needs to be up in the column heading there. And again, do L2, second 2, minus L1. And what that'll do is that'll take your syrup velocity and subtract your water velocity. So 0.92 minus 0.9 is 0.02. Okay, so now what we have is a list of all of these differences. So we can look through, some are positive, some are negative. We do have a 0. In this case, they had the exact same velocity in both water and the syrup. And we can just kind of look through and just kind of take a look at those differences. And then what I'm going to do is I am going to do one var stats. So again, stat, over to calc, one var stats. And then I'm going to do one var stats on L3. So I'm doing it on this third list, and I'm going to go to calculate, and I end up with an x bar value, and I'm just going to write these down. We'll come back to this in a minute, but x bar sub d, so the sample mean of the differences is 0.004. And what that number means is that for these 20 swimmers, on average, they swam 0.004, I think it was meters per second, faster in the syrup. Just kind of interesting. And that standard deviation, 0.0347. And that's what we call S sub D. It's the standard deviation of those difference lists. So pretty big standard deviation compared to that mean. Okay, so that's kind of what you do first is you create these difference lists. You're finding the average difference and the standard deviation of the differences. All right, and we'll come back to that data in a minute. So now what I'm going to do is I'm going to show you how we perform these procedures using these values. And what's kind of nice about the paired t-interval and t-test is basically you take your two lists, combine them into one, and then you could just perform a one-sample procedure. For your paired t-interval for mu sub d, you're going to name the procedure and identify your parameters. And what's italicized here is what you would write. So I will construct a paired t-interval for mu sub d. So that's the average. It's the average of the population differences. And then you define mu sub d. So it's the true mean difference between, and then write down what you're measuring. So when we did a 2-sample t-interval, what we said is that we were estimating the difference between two means. Well, now what we're doing for a paired test, it's a slightly different wording. Now it's the true mean difference. So again, slightly different there. And then for your paired t-test, you're also going to name procedure and identify parameters. And I'm sorry, this should just say parameter. We just have one parameter in here. So I'm going to get rid of that S because we're just estimating or testing mu sub d, which is just one parameter. And then I will conduct a paired t-test for mu sub d. And again, you define mu sub d. And then your hypotheses. So so you have your null and alternative hypothesis. What's pretty easy now for the null hypothesis is basically always going to be mu sub d equals 0. Okay, so it's pretty simple. And then your alternative hypothesis is either greater than 0, less than 0, or not equal to 0, like we always have. Okay, that's step 1. Step 2, verify conditions. Conditions are the same, so I just put the list down here once. So I said paired data come from a random sample or a randomized experiment. So in this case, like for our swimming example, you have a randomized experiment. So that was random. It was randomized which substance they swam in first, just to eliminate potentially any bias there. Sample size is less than 10% of the population if sampling was used. Actually, in this case, we just had volunteer swimmers. We didn't have any sampling, so that actually doesn't apply in this case. N sub D is greater than or equal to 30. So if you have 30 or more differences, that condition is met. Or the differences came from a normal population. That's not going to be super common, but that is one way to check that. Or the box plot of the differences show no heavy skew and no outliers. So what you can do is you can make a box plot of L3 to check that third condition. Okay, step 3. For your interval, you need a critical value and an interval. So critical value, again, is that T star. So it can be found using inverse T, where using the tail probability and degrees of freedom, where degrees of freedom is just N sub D minus 1. So you just take your number of differences minus 1. So we're back to kind of that easy degrees of freedom formula. If you're doing the t-test, your t statistic is x bar sub d minus mu sub d. Mu sub d is almost always 0 from that null hypothesis. And then it's divided by s sub d over the square root of n sub d. So the standard deviation of your differences divided by the square root of whatever your n value is. And then your p-value can just be found using TCDF, where you're using your lower t-bound, upper t-bound, and degrees of freedom. So that's step 3. And then step 4, interpret. So you would say, I am C% confident that the interval blank to blank captures the mean difference between, and then you lay out what you're doing. And then your paired t-test, again, compare your p-value to alpha to see if there is significant evidence or there isn't significant evidence for that alternative. Okay, so that's your 4-step process. So now let's put it into play here. So again, the authors of the paper concluded that swimming in guar syrup does not change swimming speed. Are the given data consistent with this conclusion? So we've already calculated that difference list. Sometimes I'll just call it the D list. And we calculated this stuff already. So this is what I already wrote down at X bar sub D and S sub D. So this is stuff that you'll have to do on your own. We had 20 swimmers, so we had 20 differences. I also could notate this as N sub D. And we're testing at the 0.05 alpha level. Okay. So I'm doing a test here because it's just asking, does swimming in guar syrup change swimming speed, right? So we're not asked to estimate what the difference is. We're just testing out a difference. So what I wrote here in step 1, I will conduct a paired t-test for mu sub d, where mu sub d is the true mean difference, okay, true mean difference between the swimming speed in syrup and the swimming velocity in syrup and the swimming velocity in water. So again, I just really clearly wrote here that the direction of my difference is syrup minus water. The null hypothesis then is mu sub d is equal to 0. And my alternative, I decided to do mu sub d is not equal to 0. And the reason for that is because it just says the conclusion was does not change swimming speed. So we weren't really thinking about, are you faster swimming in syrup? Are you slower swimming in syrup? It's just, does it change your speed? So I picked not equal to for my alternative. Then moving to step 2, it was a randomized experiment. I give you a little bit of that background. The second one I said sampling was not used, so the 10% rule does not apply. So that kind of, that second condition does not apply here. Then, since we only did 20 differences, there were only 20 swimmers, we needed to check to see if the box plot of the differences shows skew or outliers. So let me just show you that really quick. Oops. Come on. Okay, so I still have my numbers in L3. So again, I'm going to do my box plot. So second y equals, I'm going to turn plot 1 on. I'm going to select the box plot that shows outliers. That's this one here. Now, the important thing is that you change this to L3. So your X list is L3. So you're making a box plot of that difference list. And then go ahead and hit zoom and then zoom stat, zoom number 9. All right, and you can see that I made my box plot here to match what I saw there. Remember, if you hit trace, you can go through and get those important landmarks, those 5-number summary values. And we do see it does have a left skew, but we have a pretty symmetric box. Definitely this lower tail is longer. So it is slightly skewed, but I wouldn't say it has a heavy or a strong skew. So I said the box plot of the differences shows no strong skew and no outliers. Okay, so that's step 2. And then while I have my calculator up, I'm also going to show you what I did for step 3. So step 3, remember, you need a t value, a p value, and I wrote down my degrees of freedom. So what I'm going to do here is, since basically I condensed my 2 samples into one, I really just need to do a t-test. So I'm going to hit stat, I'm going to go over to tests, I'm going to select t-test, and I'm going to just go data. My null hypothesis is 0, right? That's always the case for a paired t-test. But I need to change my list to L3. Okay, I'm going to then do not equal to as my alternate hypothesis, and I'm going to go down to calculate, hit enter. Okay, so that my t-value is 0.515, so about a half a standard deviation above the mean. And remember that I'm testing that difference. Remember that x bar sub d was 0.004. So that value was about a half a standard deviation above the mean. Notice we see a very large p-value. So this is a 2-tailed test, and it's also that sample difference is not that far above 0. So we do have a very large p-value. And then I wrote down 19 degrees of freedom. So this is how you use the calculator function for a paired t-test. You just use t-test, but you do it for L3. All right, so then moving on to step 4. Now we interpret. So your p-value is 0.612. This is much greater than 0.05, so we'll fail to reject the null. And then I said there is not significant evidence to conclude that swimming speed in syrup is different than swimming speed in water. And again, that is consistent with the conclusion that the researchers got when they actually did the test themselves. Okay, so that is an example of the t-test, the paired t-test for mu sub d. Oh, and then while I have the data in my calculator, let me just also show you if I wanted to do an interval for this type of problem. So what I could do is stat, tests, and then I go to 2samp t int. Oops. 2samp t int, and I picked the wrong one. I picked z int. Make sure you do 2samp t int. And same, I'm sorry, and I said that wrong again. Okay, let me start over. So remember, you're taking your 2 samples and you're putting them into one. So you're not doing 2 samples at all. You just have 1 sample, your differences. So I'm going to go and select t interval. So pardon me, t interval. And I'm going to hit enter there. And I have my data in there. I make sure my list is L3. And my confidence level, if I could just do 0.9 if I wanted 90% confidence. And then hit calculate there. And that would be my interval, right? And I can see that it goes from negative to positive. So 0 is included in the interval. So basically that would be another way of showing that I do not have evidence that the swimming speeds are different. Okay, so that basically wraps up your paired T procedures. So these problems from the week, and I'm sorry, this should be week 5 problem set. These problems here are based on the paired T procedures, and then this assignment is due prior to your Monday or Tuesday, week 6 synchronous class. Okay, that's all I have for you today. Feel free to watch some of these AP Classroom videos, but appreciate you watching and have a great day.